Hello, I'm Isaiah Brown.
I'm Alan Nunes.
And I'm Stacy Whitby, and this is our project Trash Bin Monitor. DC has a major problem. I'm sure if you've walked around the streets of DC, you've seen multiple trash cans overflowed and just trash all over the streets. With our project, we're hoping that we can make the streets substantially cleaner.
So here's an overview of our project. It starts with the trash can. The trash can gets filled from 0 to 100%. The ultrasonic sensor will measure the distance from the lid of the trash can to the highest point of filled trash. And this distance is put out in centimeters. Then we convert that data to our Arduino, which converts it to a percentage, which is then available on our website for the Department of Public Works to view and access to better their trash can pickups. We also have a GPS module up there, but we X'd it out because we figured out a way to get better, more accurate location data within our project, which we will devolve later into or divulge later in our presentation. So with our project, we want to implement this capacity sensor into every trash can in DC. This would allow trash companies to always keep track of trash can capacity 24/7 and be able to empty them whenever they need it. This would prevent trash cans from overflowing and trash from flowing onto the streets and cluttering up our beautiful city. Here is a mock map of what our project could have looked like. We made this about halfway through our design process. So here we have two model trash cans on Google Earth. So you would click on one of the icons we have here, and a pop-up display would appear that has capacity data. So this trash can would be 25% full.
This bar chart is a model of the trash can capacity data throughout a day. Ideally, we would have liked to have an actual data chart of our capacity data, but we ran into problems with the Arduino that prevented us from doing so that we will divulge into later in the presentation. Ideally, this data would be collected over a set period of time and help trash collectors adjust their pickup times more accordingly.
So far, we've completed our prototype of a trash can, the code for the Arduino to measure capacity. We've added a radio frequency transmitter and receiver, so the data from the ultrasonic sensor, and the prototype and final prototype of our protective box for both the sensor and the Arduino. The first test we completed was measuring the capacity of the trash can. After that, we measured the angle of measurements, and then we found out how far the sensor could sense.
Our second test was to see if the GPS module was working correctly. So we took the GPS outside and monitored the data sent through the Arduino on our laptops. What you see on the screen are NMEA sentences that, when translated, give accurate longitude and latitude data and the time that that data was sent.
Here is our LoRa module. So this would be the wireless module that's best for long distance communication. And so we started researching this module, but we quickly got confused and figured out that it was not available to us because our teacher didn't have any. So we moved on to another alternative. However, this would have been best for the full citywide communication that we originally wanted. Here's our Wi-Fi module, which is best for medium distance wireless communication. And what we wanted to do with this was have our Arduino connect to a Wi-Fi network and drop its information to every available Arduino on that Wi-Fi network and receive it. Unfortunately, we couldn't figure out how to get it to work, so we also moved on from this. This is also the point where we changed our goal for the STEM fair to be have a module that can interact in a smaller area compared to a city. We would now have a mall or a school that uses the same Wi-Fi network and have the Arduino communicate that way and have trash can capacity measured that way. Eventually, we landed on the RF transmitter and receiver. So the radio frequency transmitter and receiver sends data directly through radio frequencies to its transmitter. So this eventually um, ended up being the most available option to us. It was also fairly easy to set up and use, and we got it running fairly quickly.
This is a Gantt chart that we use to track our progress to make sure that we didn't miss a due date and that we were always on track.
So if we had more time to work on this project, here are some future iterations that we would have liked to make. One would be making the container more secure and theft-proof by slimming it down and making it less visible so that people that for some reason would try to reach in the trash cans wouldn't be able to see or feel it. Our second improvement would be making the system more mass reducible by decreasing the cost of manufacturing.
Fortunately enough, throughout our progress with this project, we were able to email the Department of Public Works and we actually received a response. And we were lucky enough to have their support with our project. So we connected with Brendan Ford, someone within DPW, and he actually was able to meet one on one with us to give us support on our project, and we were able to improve our project a lot from those one on one weekly meetings.
This is a map of the trash cans around DC that was provided to us by Brendan Ford from DPW. All the colors represent the different routes that the trash collectors take when they collect trash.
And this is also why we didn't have to continue to use our GPS module because the trash can location is already provided.
We would like to take the time and acknowledge some of the people who helped us along the way through this senior project of ours. So first, we'd like to thank Mr. Stemple, who helped us set up projects, give materials like the Wi-Fi module, the Arduino, the radio transmitter, help us set up our models with cardboard, and just helping us meet due dates. We'd also like to thank one of our peers, Dominique Free, for helping us get into contact with Mr. Ford from DPW. We would also like to thank DPW for helping us with our project and giving us access to information that will help us with the future of our project. Thank you.